Hey guys, let's look at a fun probability question. So, a casino provides a game with a six-sided die where you receive a payout equal to the face value. So, we're allowed an initial roll, and if we like our result, we can stop and collect, right? Otherwise, you can choose to roll a second time, and if you're satisfied with this outcome, you can collect this value. But if you're still unsatisfied, you can roll a third and final time and take the value of this last roll. The question is determine the expected payout for this game. Okay, so essentially we get 3 rolls. And we can keep the value of the most previous roll, and we can choose to keep rolling. So how do you go about solving this question? Well, let's look at some toy examples, right? Let's say we're on the first roll. And I roll a 6, so that corresponds to $6. Well, clearly, I don't want to roll again. I want to keep the $6. There's no way I can get anything better. So we're going to keep that. What if I get $2? What if I roll a 2? Well, I think since we have 2 more rolls, then we can probably get something better in the second or the third roll. So I'm probably going to want to roll again. So clearly, there's some sort of threshold between, say, $6 and $2, right? The question is, what is this threshold? What is the threshold for re-rolling? Re-rolling the dice. And this threshold is probably going to be different between roll 1 and roll 2, right? I have a little bit more leniency with roll 1. I can afford to keep maybe some of the higher values versus roll 2. I don't want to risk getting a bad roll on the third roll, right? I'm probably going to want to take my money and run with something maybe a little bit less unfavorable. So the idea here is that we want to condition on what the previous roll was, right? So I want to roll. I want to keep the money if it's higher than the EV of the next roll. So another question becomes, what's the expected value of each of the rolls? Well, clearly, if I want to know the expected value of roll 1, I need to know what it is for roll 2. Right? And similar deal for roll 2. If I want to know when to re-roll again for roll 2, I need to know what the expected value of roll 3 is. So working backwards this way, clearly expected value of roll 3, that's just the average of the faces of the die, which is 3.5. So on average, if I choose to roll again, if I'm on roll 2 and I want to roll again, then I'll get $3.5 on average. So what does that mean for whether I want to keep roll 2 or not? Well, clearly, if I roll anything between 1 and 3, then I'll probably want to keep. I probably want to roll again, right? On average, if I do a roll 3, I will get better than 1, 2, or 3. Likewise, if I roll 4, 5, or 6, this is higher than the expected value of the next roll. So I'm probably going to want to keep these numbers. So we can plug this into a formula. So expected value of roll 2 is simply, we have a 1/2 chance of getting 1 through 3, and that's the expected value of roll 3. So this is re-roll. And then we also have a 1/2 chance of getting these 4, 5, or 6 values. And the average of those, that's 5. So when we do out the math here, we get 1/2 times 3.5. 3.5 becomes 7/2 plus 5/2. And then that simply becomes 17/4, which is equal to exactly $4.25. Okay, so we know the expected value of roll 2 is $4.25. So let's do a similar thing for roll 1. So expected value of roll 1, well, I'm going to want to keep anything below $4. So I have 4/6 chance of rolling a 1, 2, 3, or 4. And then multiply that by expected value of rolling a second time, of being on the second roll. But I can also roll a 5 or a 6, right? So I have a 2/6 chance of getting that, an average of 5 and 6. That is 5.5, or also known as 11/2. So let's see, 4/6 times 17/4 plus 2/6 times 11/2. Well, that simply becomes 17/6 plus 11/6, which is also known as 28/6. So that is 4 2/3. 4 2/3 dollars, which is 4.66. 4.66 repeating, right? So if I were at a casino and they say, okay, you can play this game for $4.75. Would you take this? No, because the expected value, if you play optimally, is only 4.66. So on average, the house will get about 9 cents as their house edge, right? Likewise, if the casino says, "Oh, you only have to pay $4.50 to play this game," then yeah, I'm gonna want to play this game as much as possible, because on average, I'll make about 16 cents. 16 cents per play. So that was a fun problem. A little bit tricky at the beginning, but once you set everything up, then it's relatively straightforward.